Hello YouTube, RJ. Today I've got a couple things in to open up and look at. Want to talk a little bit about a upcoming project, the VFO we were talking about. Want to talk about the status of where I'm at with virtual instruments, the software I was working on to show my meters on the screens. Dave over at EEVlog just did a video on Test Controller, a free piece of software that a guy over on EEVlog's been working on. Great little piece of software. Maybe take a look at it. I was thinking maybe I could use that in the lab. Kind of that didn't work out, but not because of the software. It's great. So I'll talk about that and tell you how that made me think in a different way and what I'm doing with that. Hey, let's get started. Start out by, I got a Mauser order in. And man, I had no idea that many of you wanted the little Lynx EZ radio kit. Wow, them things quick. I think maybe as of the time I'm making this video, I might have like one left. Don't think I'm going to be able to do any more kits soon due to the tariffs. That's going to jack us up on all that. So we'll have to wait and see what happens with tariffs. Maybe I can do some more kits, once all that's worked out. If the cost is still, I can keep the cost reasonable. Anyway, I've got a bunch of parts in from Mauser for our VFO project. I wanted to restock a bunch of my really top shelf caps. I went ahead and picked up some 2222 ends from Mauser to know I had genuine. Same with 3906 and 3904. I got just a few of them. I've got plenty of them in my little kits of cheap parts that I use normally on the breadboards and stuff. But for this project, I want to make sure I'm using premium parts. Yeah, some 10 picofarad C0Gs, some 100 puffs, a couple JFETs. So anyway, we got parts to work with. That's what that was. And let's talk about the next thing, and that's building this VFO. Got some better parts to do it with. I've got an enclosure. You saw in the last mailbag opening I did, I had that cast aluminum enclosure. I'm going to use that for it. Well, I don't know how many of you remember this. I seen this on eBay, and I think I paid $4.99 or something for it. And it was more curiosity. I just impulse bought it. And what it is, it's a little RTD thermosensor simulator. We opened it up. I'm going to open it up again. We opened it up, if you remember, and played around with it a little bit. And it seemed like it didn't quite do what I would have thought it would have done. But the problem was I went online assuming I could get a manual for it. I could not find a manual. But at the time, you might remember me making the comment that that's okay. I only paid $5 for this thing. And the pots in this thing are worth way more than that to me. So anyway, here it is. It's got some really nice multi-turn precision potentiometers. And I think I looked them up, and you probably remember me. I'm old and getting senile at this point, but I think I looked them up, and they were like 35 bucks a piece or something like that for the potentiometer. So, it didn't do too bad for $4.99. As you can see, they're multi-turn potentiometers. And I'm just thinking, if you want to do a voltage controlled frequency oscillator, normally you need a veneer control or something that allows you to turn multiple times to turn your variable capacitor or to turn your potentiometer. What if you just used one of these precision potentiometers out of this thing? You get a multi-turn without any gears with slop in them or having to build anything to do it. You get it right in this potentiometer. This potentiometer is designed to be very precise and so my thought is maybe these would be the perfect pot to use. So I'm thinking about stealing one of the pots out of this for our VFO. So what do you think about that? The switch and pots are worth more to me. The switches and pots are worth more to me than that. I've got there's also some trimmer pots here. Very nice trimmer pots. So the parts in this thing is worth way more than the $4.99 I paid. So, sometimes you look up like that. So I'll set that over to the side. Okay, now let's take a look at what we got right here. This is another tool from AliExpress that I ordered. Found it very reasonable price. I'll put it on the screen because I can't remember right now, but I was finding it for like 70 bucks on Amazon and even on AliExpress I was finding it way up there. This is before the tariffs kicked in. What it is, it's another tool, another piece of test equipment for the lab. You might remember I got a new toy and showed off to you guys the other day, and we didn't really try it out yet because I said we would. Let me get it. The DCA 75 Pro, if you remember, we got. I said we would use that. You get to see it when we do the next talking about transistors segment, which is coming. This does a lot of neat things with small signal transistors and tests a lot of things. It doesn't test one thing, and that one thing that would help you tell if something's a fake or if it's not good. And so that's where this comes in. This is another type of transistor tester. And this particular transistor tester, didn't even realize it had a nice case with it. That's nice, or reasonably nice case. This is a DUOYI. Do not know how to pronounce that. Won't even attempt it with me. It would be just something else for you guys to laugh at me about. It's a DY294. The top just pops off like that. I thought it was coming out of the case, but I remember now it's like this. This is a high voltage tester. This thing will do up to 1,000 volts and let you test the breakdown on the transistors. You've got NPN, PNP. You can test the different HFE, which we can do with this, with the peak. But what you can do with this is you can actually test breakdowns all the way up to 1,000 volts. That's pretty cool. Now, the only thing I don't see is I guess it has batteries in there. Guess I better get the instructions out. I'm wondering if it's got batteries because I see a plug for 6 volts, but I did not get anything to power it with. So I assumed it was a battery powered device, but let's take a quick look. It says it's a test that is mainly used for measuring the DC parameters of various semiconductors such as diode transistors, tracks, and field effect transistors. It can also be used to measure the withstand voltage of capacitors, protective voltage of varistors, and insulation of electrical appliances. 78 and 79 series 3-terminal voltage regulators can also be measured. So this allows me to do tests I can't do with this. So again, we'll use this in the talking about transistor series. I am looking, where do we put the battery in? You'd think they would tell me. Loosen screws on the bottom cap, remove it. Pay attention to the polarity of the battery when placing the batteries. It says it's 4 AAs. So apparently they didn't give me batteries with it, or it's defective, one or the other, because it is not coming on. So it says make sure don't touch the terminals when you are on doing the breakdown test because 1,000 volts hurts. So you're seeing exactly what I'm seeing, exactly the way it comes in. So if you buy one, at least in my case, doesn't come with batteries or they're dead, one or the other. Nope, didn't come with batteries. Let me grab some AA batteries. I'll be right back and we'll see if this thing turns on and we'll give it a try. You guys give me so much slack about the Duracells in the past videos that you freaked my wife out to where she's buying Energizers now. Hope y'all are happy. Alrighty. Now, does it turn on? Yes. Any protective film on this? I'm sure there is something there. So let's see if I can get it off of there. There we go. Here comes the big pill. Oh yeah. Oh yeah. There we go. That looks a little clearer looking. Okay, so you got a high voltage button here to tell you that you're putting voltage out. I've got to read a lot on it, but I tell you what we can do. I've got a little transistor here. What do we got? Got different slots here for different. Looks like I got a little piece of plastic right there. Oh, a little piece that didn't come off here too. No, I just kidding. Just kidding. I'm not pushing the button, guys. I just had to do that. Remember, this thing does put some good voltage out, so. Anyway, I got that little piece of plastic out. Anyway, let's see, what have I got here? This is a 3906, it looks like. And it should be an EBC, if I remember right. I think that's right. Probably ought to read the instructions, but you know, sometimes it's fun to try to do it without it first. Let's go to 200 volts. It's a PMP, so let's try. The breakdown voltage is 72.5 volts. I wonder what it's supposed to be. Through magic, I'm going to do a little editing and get an answer. Okay, the collector to emitter and collector to base has to be 40 volts minimum. We're doing that. The thing is, I had no way to test breakdown voltages, and that was the main thing I wanted out of this. Also, this will do power transistors and stuff that this one can't generate enough current stuff for. So between the two, we can do some nice things. This doesn't do curves. It doesn't recognize devices and tell you what they are or what pin they are and such. This the peak does. The peak's very nice, but this is going to fill in for those other times when I want to know breakdown voltages and maybe higher currents and such like that. And let me turn this thing off. We're going to take a quick look at what I'm doing with the virtual instrumentation. So I'm going to clean the bench off, set up to show you. I'll come right back. Okay, I got things reconfigured where you guys can see my O1 power supply, my little SPE 6103, and my XDM 1041 Owen voltmeter. And the reason I did that is because we're going to jump over to the screen now and look at what I'm doing with virtual instrumentation. So you probably remember I've done work where I've popped up the little boxes I've created that shows my meter reading so you guys could see what my meter was reading while I was doing things. I took a look at the video from Dave over at EEV blog the other day when he was talking about test controller software, and I took a look at it. It was cool. It worked really well. I could connect up my stuff. And I even thought that maybe I could just use that. But when I looked at it, the presentation wasn't very clear. It was grids with lots of equipment, and everything a meter can do, such as my signal generator. You know, it's got 2 channels of signal generation. It's got a frequency counter. It breaks all of that down into multiple lines. And so there's no showing you what frequency it's showing or showing you what frequency it's set to. You got to see this grid with all of these parameters, and hard to track and know what you should be looking at. And I got to thinking about, you know, what I'm doing, good idea, but it could be nicer. And I got to thinking, how would it be nicer? You know, ultimately, a camera for each meter for you guys to watch would be awesome, but it'd be in the way. There'd be no way I would have space on the bench to even work. And I got thinking, well, could I kind of do that? I mean, I know my truck, it pops up a backup camera, but it also pops up an overhead view down on my truck, and it puts a simulated little picture of my truck. I can see all the way around my truck, and I thought, could I do that kind of a similar kind of thing with the virtual instrumentations for my lab? And so I went to programming, and I was up late last night programming, and I've got the 2 Owens done, and I'm going to start on my LCR meter and my arbitrary signal generator and frequency counter. But I've got them done. I want to show you what I'm doing, and give me some comments. You think it's cool? You think it's stupid? It's a dumb idea? We don't want to see that. Here's what I come up with. Let me jump over to the computer and let's pop up the Siglant meter. Here's what I ended up with. An actual image of the meter that works. If I turn it on, there is my ON meter, and all of the information on the screen shows as it does on my meter. And so you can instantly look up here and recognize what you're looking at and what the readings are. I've also got one for my power supply. Let me pop my power supply up. Here's my power supply. So you can instantly tell. Let me connect to that. You can instantly tell. And if you notice, it populated in here. These little numbers in here are the little numbers here that tells me the set voltage, the set frequency or amperage, and what the limits I have it set to, the maximum that I have the protection set to. And then, of course, I show you the volts and the amps. It looks a little different than the screen because I have the graph up, but let me see if I can remember how to do this. There you go. That's what the screen I'm supposed to be on. So you can see it looks like this. Now, I want to tweak that a little bit. I want to make these fonts a little bigger to match up with this screen a little better and line this V&A up a little bit. But, you know, I knocked off last night. It was getting late. You get the idea. What do you guys? You think that's a good way? I can actually video record these while working, just like I did my little programs, and can pop them up on the screen up there, and you can see as if you're seeing what I'm seeing on the bench. You guys let me know in the comments. What do you think? You like this idea? Would this be nice to see as a little meter up on the screen that you're seeing the meter that I'm seeing? So hey, Thanks for tuning in today. Hope you enjoyed it. Hope you'll give me a little feedback on the virtual instrumentation idea. And you know, if I get these done, get them working really well, anybody else that's got these meters that are interested, and I'd be happy to give the software to you. It's Windows based. Appreciate you watching. Hope it was a little entertaining, and I hope to see you in the next video.